Electrical machinery 2. Subject. Good morning to all. First unit. Alternator. Synchronous generator. Predetermination of voltage regulation. The rise in terminal voltage of alternator when the full load is thrown out of alternator excitations and speed remains constant. This percentage variation is defined as regulation up or up regulations, down regulation or regulation down. It is the percentage variation of terminal voltage when a full load is thrown into the alternator. Percentage of regulation is A0 minus V divided by V into 100. Large measures the cost of finding the regulation by direct loading becomes prohibitive. Hence, other indirect methods are used as discussed below. It will be found that all these methods differ chiefly in the way the no-load voltage E0 is found in each case. First, synchronous impedance or AMF method. This is due to Becken Eschenberg. Second, the ampere-turn MMF method. Third, zero power factor at Portier method. All these methods require first armature or stator resistance RA. Second, open circuit no load characteristics. Third, short circuit characteristics but zero power factor lagging characteristics for Portier method. Value of RA. The measurement of RA circuit shown in figure. Alternator is connected to ammeter and voltmeter. Supply is given. Armature resistance RA per phase can be measured directly by voltmeter and ammeter method or by using Wheatstone bridge. However, under working conditions, the effective value of RA is increased due to skin effect. The value of RA is so often is increased by 60% or so to allow for this effect. Generally, a value 1.6 times the DC value is taken. Open circuit characteristics is in DC machines. This is plotted by running the machine on no load and by noting the values of induced voltage and field excitation current. It is just like the BH curve. Open circuit characteristics circuit shown in figure. The alternator connection is known. The graph is given between E0 and IF. Short circuit characteristics. It is obtained by short circuiting the armature, that is stator winding, through a low resistance ammeter. The excitation is so adjusted as to give 1.5 to 2 times the value of full load current. During this test, the speed, which is not necessarily synchronous, is kept constant. Synchronous impedance method. Following procedure steps are involved in this method. That is, OCC is plotted from the given data. Similarly, SCC is drawn from the given data. Short circuit test. It is a straight line passing through the origin. Both these curves are drawn on common field current base. Consider a field current IF. The OC voltage corresponding to this field current is E1. When winding is short-circuited, the terminal voltage is 0. Hence, it may be assumed that the whole of the voltage E1 is being used to circulate the armature short-circuit current I1 against synchronous impedance ZS. E1 is I1 ZS. ZS is E1 open circuited by I1 short circuit. Since RA can be found as discussed here, is XS is equal to root of ZS square minus RA square. Knowing RA and ZS, vector diagram as shown in figure can be drawn for any load and any power factor. E0 is E1 value is I1 ZS. ZS is synchronous impedance. Total internal drops E1. ZS is equal to E1 divided by I1. Vector diagram shown in figure, shown in notes. ZS is open circuit voltage divided by short circuit current. A0 formula is root of V cos phi plus IRA square plus bracket of V sin phi plus IA XS square bracket whole square. Where XS is equal to root of ZS square minus RA square. Under short circuit condition, the value of voltage is 0. Under open circuit condition, E1 is the generated voltage. Hence, it may be taken as the voltage is generated or measured as internal drops. That is synchronous impedance method. Graph is drawn from OCC curve and SCC curve. From this graph, we obtain E1 and IF and ISC values and I1 values. From these values, we obtain record value. Synchronous impedance method vector diagram and graph is shown in notes. Thank you.